So, have you ever been afraid of being read by a car when you're running at night? Well, we might have the solution, and it's also fun.
The KemereShoe. Our system is a system that attaches a sensor to the inside of the sole on your foot and runs a string of LEDs up your leg. And as you're running, it flashes the LEDs in a fun and exciting pattern that will also warn cars that you are in front of them.
So, the sensor we have to sense whenever you touch the ground is called FSR sensor. It's a sensor that basically, whenever you apply a force to its surface, it generates a different resistance, and we can read it with the MSP430. So the FSR sensor consists of a sensing film made of ink, and this sensing film has both electrically and
Conductive and non-conductive.
Electrically conductive and non-conductive particles. They are floating, and whenever you apply a pressure over it, the particles will contact an electrode, and then will change the resistance.
Lower the resistance, yeah. And the way that we implemented that in a circuit is just by sticking the FSR in a simple voltage divider, so that when you step the FSR, the resistance goes down, making the voltage at this point increase, triggering an interrupt in the FSR. And we also put a capacitor in here for hardware debouncing. And so that generates interrupts in the MSP430, which we counted.
Okay, so we'll have an LED strip of 30 APA 102 LEDs, the same we're using for the labs. So this time, since we have 30 LEDs in a string, we had to have a better clock, like higher clock, faster, so we could actually send all bits before the next cycle happens.
We also put a 300 ohm resistor in front to reduce voltage spikes, so that it takes a little bit of time for the voltage to cross.
So we are also using an LCD display, 16 by 2. It has two modes, the 4-bit mode and 8-bit mode. We choose for the 4-bit mode to reduce the number of ports we are using for, in the MSP430.
So it's the same thing we use in our midterm. It uses 2 control signals and 4 data buses. Not very convenient, but it gets the job done. It has a nice little display, parallel communication.
Yeah. Different from the midterm project, this time we can unplug and plug the LCD. So to do this, we had to actually use a port 1 interrupt, so we can send the necessary commands to activate the 4-bit mode. So it has a pull-up resistor internally in the MSP430. We have a capacitor for the bouncing, and here we have the interrupt. Actually, we have the LCD plug.
And basically, as you can see, there's just 2 pins on the actual physical LCD that are shorted together. And when it's plugged in, that short just connects this pin here to ground, pulling the signal low and generating an interrupt.
Yeah, summarizing, the LCD will work as a switch to activate the port 1 interrupt. So a little bit of code now.
Yeah, so for the code architecture, basically we spent most of our time in low power mode 3 to conserve power, although most of the power of our system is actually drained by the LEDs, because they're on pretty high, so they drain a lot of power. But our system is in low power mode 3 until this interrupt occurs, and then it turns on the system and sends it into the main loop. In the main loop, in the main function, we set up everything so that we measure the time between our last step and the one we're currently on, and break that period into 59 shorter periods. And we set up timer A1 so that each time that shorter period happens, we move the LED on the leg 1 step in whichever direction we want it to go. In the main loop, we also do all the calculations for what our colors should be, but we also do a little bit of that in our timer as well, because we change the color a little bit as it goes up and down the leg, so that it's a seamless, smooth transition. So yeah, and that happens 59 times, and then it gets to the end, goes back into low power mode and waits for the next interrupt, unless the interrupt happens before it's done, in which case the interrupt overwrites the last cycle and just starts a new one from scratch. So that accounts for either increasing speeds of running or decreasing speeds of running. The main loop is actually a 2-part main loop. We have 2 modes in our system, one for when you're actually running and one for when you're stopped and reading the LCD. And in that one, we have a loop that runs once and then waits for the next interrupt, that initializes the LCD and sends the relevant data to the screen. And we do that interrupt by waiting for the interrupt on port 1, that comes from plugging in, and then we use the watchdog timer to wait for long enough so that it's fully turned on and the connection is stable, and then we start sending the data. Other than that, we use timer A0 in low power mode 0 to do the waiting for the communication. For our system, we actually had to use low power mode 0. Or so we also had to use low power mode 0 for transmitting transmitting to the LEDs, and we used timer A0 for 2 functionalities. We used it to wait for the LCD when we're in reading mode, reading the LCD. And when we're running, we use timer A0 to keep track of the time, to keep track of when your steps are happening and how long you've been running for. So we switched the clock source for timer A0 depending on which mode we're in. And when we're using the LCD, we're in low power mode 0 transmitting, and when we're running, we're in low power mode 3 most of the time.
Most of the challenge we had in our project was related to mechanical connections.
Yeah, so we used an external battery actually that we did not put on the PCB because it was a long string of LEDs, we needed a larger voltage source. So we used a 3.71 that is external. So there was a connection for that kept slipping, and that really caused problems with our system functioning. And also the connection with the MSR is kind of loose as well. And so when that kept connecting and disconnecting, it would generate interrupts that we weren't supposed to have. So those are both problems. We had to do a lot of careful soldering, and so as not to overheat the battery or anything, to make those connections nice and solid, but while still being unpluggable and repluggable with jumper pins.
Okay, so now it's time to actually see it working.
Alright, here comes Vitor out for an evening run. It's dark at night, but luckily cars can see him because he's wearing the handy-dandy KemereShoe. As he comes back this way, you can also try to see that as his foot hits the ground, the red one hits the ground as well. We'll have some slow-mo pictures for you so you can see this a little bit clearer later. Yeah, if he goes a little bit faster, that blue becomes more green and the red becomes more red. And as you can see, the dots stay in time with him running. Alright, and Vitor's getting a little tired now. So I think his evening run is going to come to an end. And as you can see, as he's walking now, if he just takes a couple steps to walk, yeah, as you can see now, that dot looks more yellow. Okay, so now he's going to stop, and he wants to see how well he did on his run today, so he plugs in his LCD display. It powers up and tells him that he has run, I think we'll focus, 109 steps for 1 minute 51 seconds. Well done, Vitor.